Hi everybody, this video today is going to cover section 9.4. We are still dealing with the same angles that we've been dealing with this whole time, corresponding, alternate interior, same side, and alternate exterior. And this time though we're dealing with the converse. And what is a converse? Well, the converse is when you have an if-then statement, but you switch the if with the then. And once again in this one I have to warn you there's a lot of writing, so if you want to abbreviate or whatever, I tried to abbreviate in here, but you all can abbreviate even more if you want to. Anyway, we're going to switch the if with the then. So for instance, corresponding angles. If two parallel lines are cut by a transversal, then corresponding angles are congruent. If I switch the if with the then I say if two corresponding angles are congruent, then the lines are parallel. And I should say I should have a congruent mark over that one and over this one and all throughout here. So we'll fix those. Okay, so alternate interior. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. If we switch it up, we'd say if they're congruent, then the lines are parallel. If they're congruent, then the lines are parallel. Same thing with same side interior, except with same side interior, remember that's the only one that says supplementary instead of congruent. But again, if two lines are cut, then the angles are supplementary. If the angles are supplementary, then the two lines are parallel. Same thing with alternate exterior. If two lines are cut by a transversal, then they are congruent. If they're congruent, then the lines are parallel. It's just switching the if with the then. So this is going to play out in some different equations. Notice that these are same side interior. Remember, same side interior are the only ones that are supplementary. And supplementary means they add up to 180. So we're going to say x plus 4x is equal to 180. That's 5x equals 180. And so x equals, we're going to divide by 5, x equals 36. Okay, doesn't that look exactly like what we've been doing? It's just they're changing the question. They're saying what would create them to be parallel. Let's take a look at another one. These are what kind of angles? These are corresponding angles, and of course we have corresponding angles and they are congruent. That means we set them equal to each other. So we're going to set 2x plus 1 equal to 3x minus 5, and we're going to solve. You can subtract either way. I kind of think I'll just subtract the 1 over here, and so now I have 2x equals 3x minus 6. And now I need to move my x, so I'll move my 3x. And you could have gone the other way, but this is just how I did it this time. And we get negative 1x equals negative 6. So if we divide by negative 1, then we get x equals 6. That was all for this example up here. And again, what we're saying is, when it's that number, then they're going to be parallel. If it's x is 6, then these are parallel. We're not going to do every single one. We can do one more of these. We should say what kind they are. These, once again, are corresponding, and we know that corresponding angles are congruent. These are alternate interior, and we also know that alternate interior are also congruent. Since we've already done, didn't we already do a corresponding? We did. So let's do this one instead. We're going to set these two things equal to each other because they are congruent. When they're congruent, we set them equal to each other. So I could subtract my 8x, and that's going to give me 5 equals 2x minus 7. So I can add the 7, do the opposite, add. And so that's 12 equals 2x. I divide by 2, and I get 6 equals x. And so once again, what it's saying is when x is 6, that's when these two lines are going to be parallel to each other. All right, let's turn the page. All right, so more of these. I don't think we need to do all of them, but maybe it'll be good to do another. This one is also same side interior, and same side interior are supplementary, and supplementary means they add up to 180. So let's try one more where they add up to 180. So 3x plus 20 plus 5x minus 8 equals 180. Remember, when they're on the same side, like on the left here, we add the 3x plus the 5x together. And we just say it's 8x. And then we add the 20 and the minus 8 together, and we say that that's 12. And now we're going to just solve this equation. So we're going to subtract 12 from both sides. 180 minus 12, I believe, is 168. And then I'm going to divide by 8. And so I get x equals 21. So just a couple things. Same side means supplementary, means I add up to 180. When you have all the stuff on the same side of the equal sign like this, you just combine them together, combining like terms. We combine our 3x and 5x, and we combine our 20 and our negative 8. Okay, down here we're going to get into some of this kind of baby proof practice that we do. Okay, so for instance, I'm going to fill in what I know. I know that angle 1 is congruent to angle 2, goes here because it's given. I know that m is parallel to n is going to go down here because that's what I'm looking for. The question is, what is the reason? If we look at the angles, 1 and 2, those are corresponding angles. But what we're talking about in this unit is this section today, is that this is the converse. That means that it's the backwards one, where another way to say this is if we have corresponding angles that are congruent, then we have parallel lines. Okay, so it's just kind of saying a little bit backwards. And I think that this way at the bottom, that's how they're saying it in EdSite, so that's why I wanted to talk about that. Okay, next problem, angle 4 and angle 5 are supplementary. I wrote that in here, it's given. We're trying to prove that G is parallel to H. Let's look at 4 and 5. Here are 4 and 5. What kind of angles are those? Those are same side interior. So what we can say is if, and I'll abbreviate this, same side interior angles are supplementary, then the lines are parallel. Or another way to say that is a same side interior angle converse. Either way. But again, I think the way they're saying it in EdSite is this top one. Okay, let's turn the page. All right, there are two kind of longer proofs on this page, but I think we can do those. And then the one on the last page we'll save for class. Okay, I'm going to fill in all the easy stuff. So I have my givens here. I have my last one here. Then in this reason, I'm going to start to fill in if blank angles are congruent, then the lines are parallel. That was the reason we kept coming up with on the previous page. So I think that's what's going to happen here at the end. When I look at these, I have to start with looking at L and M. And then after a little bit, I'm going to get to 1 and 2. And then after a little bit, I'm going to get to A and B. So I just start with L and M. And if I'm starting with L and M, then let me show you what some of the options would be. We could say maybe 3 is congruent to 5. Or we could say that 1 is congruent to 4 because of line L and line M. So since this one already has a 1 and a 2 in it, I think we ought to start with 1 and 4. So let's do that. We're going to say that 1 is congruent to 4. Remember how we have to like go around the block? So let's just say that angle 1 is congruent to angle 4. And the reason for 1 and 4, let's take a look. That's because they are corresponding angles. And so I forgot how they word it in the EdSite, but we're going to say that corresponding angles are congruent. And that's the one that's a postulate or a theorem or something like that. Okay, then 1 and 2 is given. Looks like maybe since we go 1 to 4 and then 1 to 2, my kind of guess here is we're going to go angle 4 to angle 2, the next one, because that will let us use the transitive property. Now, since I said that was a guess, let's take a look at the diagram and make sure that's going to work. So I'm saying 4 and 2. Yeah, we could go from 4 to 2. From here to here, those are corresponding angles, and they deal with line A and line B, right? That's how we're working here. So we're going to say angle 4 is, okay, that's true. Then I'm going to fill in this piece that I had left empty. I know that I have congruent angles and then I have parallel lines. What kind of angles do I have? So if we look at 4 and 2, 4 and 2 are corresponding. So I'm going to fill in that space there. I'm going to fill it in with corresponding. If corresponding angles are congruent, then the lines are parallel. We don't always use the same, corresponding and corresponding. Sometimes one of them might be alternate interior or whatever, but this one worked out to where we just went corresponding to corresponding. All right, this will be our last proof for this video. I'm going to fill in the easy stuff. So C is parallel to D, given 1 is congruent to 3, given, and A is parallel to B. I'm not sure, but the one that we keep using is if blank angles are congruent, then the lines are parallel. So that's probably going to be our reason here. Let's take a look at the diagram. We need to get, first of all, find some angles with C and D. Okay, let me tell you something. Let me tell you what we're not going to do. We are not going to get 1 and 4. And you might say, why not? Well, the reason why not is we're supposed to do C and D, but if we do 1 and 4, we have not involved D at all. And if we say C and D, we have to do something with D also. So 1 and 4 do not work. So we're going to not do those. So what will we do? Well, we could either do 4 and 2. Those look like corresponding angles. Or maybe 4 and 3. Those look like alternate exterior angles. So I think either one of those would work. But I'm going to look at what I have. And I know this is a 1 and a 3. So maybe instead of the 4 and the 2, I might stick with the 4 and the 3. Because that 3 is here, I want to get at least one number that's the same. Okay, so I'm going to say angle 4 is congruent to angle 3. My reason, those are alternate exterior angles, and alternate exterior angles are congruent. So that's my reason. Again, that's a postulate. I think that one's actually a theorem. The next one is a given. So now our typical thing we do here is we use the transitive property. And if 4 is congruent to 3 and 1 is congruent to 3, then let's skip the 3's and just say that angle 4 is congruent to angle 1. All right, now those were the ones I said we couldn't do in the beginning. The reason we couldn't do them is because we were doing C and D, but now we want to do A and B. And so yes, now 4 and 1 are the ones we want to work with because they're touching A and B, which is what we want. And so what kind are they? Those are alternate interior angles. So if alternate interior angles are congruent, then the lines are parallel. That's our reason. All right, we'll work on this a little bit more in class.